All right, so last class was probably one of the, I don't want to say more important, but it was a pretty big, important class because we did the following. We talked about what are called binomial experiments. And what's called the binomial distribution. So we could write this formula down, and it's scary and it has lots of letters, but it also has some symmetry, which makes it a little, excuse me, a little easy to memorize, or easier than some formulas, I should say. And also, what we have is that it's somewhat intuitive because of the nature of the formula. So basically the formula says this. It says the probability that a binomial random variable. So remember, anytime we write a big X, we think of that as a random variable. So the probability that it equals some number K is equal to n choose K, this binomial coefficient. And then it's P to the K times 1 minus P to the n minus K. So let's remind everybody of what these numbers mean. So this is, let's clean this up actually. This looks kind of sloppy. That's a P. So first off, there's two P's floating around in this particular formula, and that you have to use some context. It's also important to note that this guy over here, this means, let's kind of say exactly what this reads. You'll remember that this thing reads the probability that the random variable X equals K. This guy over here, if I can get a different color, this is what's called n choose K. We talked about that when we were counting before. We're just giving it a new notation. I told you that it's what's called the binomial coefficients. And then lastly, this number P, well, the number P, what does the number P mean? Well, the number P represents the probability of success whatever success is in your particular problem. And then this is the probability of quote unquote failure. So remember, what is a binomial experiment? A binomial experiment is one where there's one of two options, heads or tails. You roll 7 heads, or excuse me, you flip 7 heads in 10 tosses, or the loan defaults, the loan doesn't default. binomial means two, or it shouldn't say binomial means two, but a binomial experiment means it's an experiment where the random variable in which you are studying has one or two outcomes. Excuse me, two outcomes. One we call a success and one we call a failure. So I think it's important that we do some more examples of this. So that's what we're going to do today. And yeah, the watcher, this gives you anxiety. See, that's the thing. All these are scary formulas, and they're scary because you're not used to using them. But if you use them, they become less scary. It's like anything else. We're always afraid of what we don't sort of understand, what's different. And so what we want to do is we want to practice with it, and then it no longer becomes something that gives us anxiety. It's just colored marker on a whiteboard on the computer. As I sit at the beach with a Cookie Monster sweatshirt on. This is good stuff. Does anybody have a question? Comments, concerns? Okay, so let's do an example. I know we did some examples last class, but it's worth doing some again. Just because this is an important distribution. Okay, so let me get a sip of the water here. Okay, so so a research study takes a survey and determines the following. Determines 6% of adults would prefer to live in a city on the coast. Okay, so so let's assume that we take some arbitrary collection of people. So we basically what we're saying with the setup here is we're saying that 6% of Americans would prefer to live on a city that's on the coast, maybe somewhere in California or Washington or New York or Florida. Now I'm being very arbitrary, but that's not the point of the problem. The point of the problem is the 6% right now. So let's assume that we talk to 20 random adults. Number one, exactly 5 want to live on the beach? So again, we're going to ask 20 adults, and what we want to know is we want to know what's sort of the probability that exactly 5 want to live on the beach. The second thing we want to ask or answer, the probability, if we will, that at most 3 want to live on the coast. And then last but not least, we'll change the problem. What about the probability at least 3 want to live on the coast? So, yeah, Melanie, you're asking if this relates to any of the homework. Absolutely. And it's going to relate to the next homework too. I think the last 3 or 4 problems on, let me pull it up. So if you look at homework 7, homework 7 problems 9, 10, 11, and 12 are similar to this. And then in homework 8, which I've yet to assign, is going to have questions like this as well. So to answer your question, yes. Homework 7 and soon to be 8. Happy Thursday. One of the things too, it's worth me pointing out, since you asked the question, and I'm not going to pick on you, Melanie, but I'm just, you asked the question. So here's the thing. One of the problems that sort of keep us from learning, math is a great subject for this. It's because so much of your education in grammar school, or whatever the heck you call it, K through 12, whatever the silly words you want to use, so much of your math education then is about learning procedures and repeating them. That's not mathematics, though. That's just not. Mathematicians don't sit at home and memorize procedures and then do them. That's just not what mathematics is about. Mathematics is about problem solving. It's a language that's used to answer questions. So right here we have a problem where you have sort of this silly made-up scenario in real life, and we want to use a mathematical tool to analyze it. And so we get in this habit of thinking, how to, you know, I hear this all the time when I'm teaching classes. It's or I'm working with students. It's what's the answer? What's the answer? How do we solve it? Solve. That's not actually what we're doing all the time. Right now, what we're trying to do is we're trying to use this new tool to sort of think about how it gives us quote unquote answers to things. So, you know, I caution you to think, is this the exact same thing as another problem? Because what makes this sort of stuff difficult to learn is that there's not some sort of poster child problem where if you learn how to do this problem, everything else is exactly like it. That's just not how it works when you start learning about things like the binomial distribution. What we're trying to do is we're trying to get you to take a problem and formulate it so that you can apply a tool such as the binomial distribution. And then later on, we're going to ask you to do similar things. We're going to give you a quote unquote problem. And you're going to have to find a way to formulate it so that the tools that you have at your disposal can apply. So I know that's like a long-winded way of answering your question, but that's, you know, that's a more accurate answer than me saying this is just like problem 7, blah, 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 because they're not all the same. Each problem has its own little uniquenesses. But you will see, and this is important to understand, you will see lots of the same themes. So you'll see certain phrases like exactly, or at most, or at least. And what you want to do is think about how you handle those phrases in one problem, because the way you handle those phrases in one problem will be exactly how you handle those sort of keyword phrases in every other problem. So right now I'm looking at homework 7, and if I look at problem 10 on it, I see exactly 2 heads. And in problem 11, I see at least 2 6s. So if you look at problem 12, we see at least 15 out of 20. So those are all problems that are very similar to what I'm doing right now. You'll notice in part 1 of this problem, I'm saying exactly. So that's just like number 10. And then I'm doing at most. And then I'm doing at least. So that's very similar to 11 and 12. So I hope you'll use, you know, if you want to learn this. And again, I can't force you guys to want to learn it. And you're not going to learn it overnight. It takes practice. It takes some resolve. It takes knowing that you're going to, you know, mess it up the first few tries. But if you say, okay, screw it, I'm gonna learn this, then once you learn it, you're like, okay, it's not that bad. But that time frame for most of us to learn this is not listening to me babble for 10 minutes about it. That time frame is not you watching this lecture later or looking at the whiteboards. The time frame for you to learn it is going to be you doing it on your own, not watching me, not watching other videos. Sure, those help, those assist, but you really haven't learned it until you can try and fail, and then try and succeed on your own. So anyhow, I'm babbling, but what the hell else is there to do? It's a beautiful day outside. Even here at the beach, it's a beautiful day. Okay, so look at my blue screen. The disappearing, if you're paying any attention, it's the disappearing chemicals, the rock star. Okay, so before we solve this, and you could solve this right away, but let's sort of put, good news is Pitt claims they have a vaccine. They're going to announce at 11 o'clock this morning. Maybe the Roni virus will be out of quarantine before you know it. Okay, so does anybody else have a question? Want to talk about anything? Life. Okay, so let's write down all these sort of words, the verbiage that goes with this before we do any types of formulas. So let's get a new color. We'll use this little blue. I like this blue. Solution. Okay, so what we want to do is let's get our terms straight. That's what I want to do. So I want to make sure I understand what everything represents. What letter is going to represent this? What letter is going to represent that? What are we calling a success? What are we calling a failure? So so let's do that. We need a new page. So just to remind you, we have some numbers floating around. We have 3 floating around. We have 5. We have 20. We have 6%. We have lots of numbers floating around. So let's do that. Order it up. Okay, so what is our random variable? What are we studying? Well, we're studying a person. We're saying, let's take 20 people. Now let's look at each one of those people as a questionnaire or a trial. I say to person 1, do you want to live on the beach, or are you happy where you're at? They're going to say yes or no. Beach, no beach. Coast, no coast. So if we're going to ask 20 people that, and if we go back to these phrases, let's go even back 1 page. The very first thing we wanted to know is that exactly sort of what is the probability that if 5 of those 20 people want to live on the beach or live on the coast. So what should our random variable be? What is X? Well, a good way to think about this is look at the question like 1 and ask yourself, okay, if I wanted to write that with P in parentheses and numbers, how would I do that? So one way you might think of this is the following. So let X equal the number of people who want to live on the coast. Now, what values can X be? Well, we're only asking 20 people, so X can be 0, 1, 2, 3, 4, all the way up to 20. So again, I would encourage you to think about this as the following. This is structurally no different than the problem of flipping a coin 20 times and counting the number heads. So, you know, this again, I'm not saying it's easy for our brains to get this. I mean, it's one thing for me who's been studying probability and math for 20 years and who likes this and does this stuff all the time. Some of this is for me, I have to remind myself that when I didn't know it, when I was in your shoes, I had no idea what in God's name the instructors were babbling about. But really, a great exercise for you is to convince yourself that this is, if you remove the words, if you just think of the mathematics, that this is the same exact thing as me flipping a coin 20 times and counting the number of heads. That's it. It's the same exact thing. Okay, so does anybody have a question, comment? Does anybody want to say, I hate you? No, you shouldn't say that. Although I shouldn't joke about that. Liam, you usually will tell me something funny like that. And I say, this kid is funny. Liam, what kind of shirt do you have on today?
It's just a We Came as Romans t-shirt.
That's a good one. All right. We Came as Romans.
It's a band.
I know. I told you, my brother-in-law is a music dude. there's anything, if there's, he goes and sees a band called Piss Jeans. I don't know what the hell that is, but they're a band, and it gives me the ability to say pissed jeans and not be cussing because it's the name of something.
Yeah, but that's the same thing with this like one band. Like if I just go onto like what is it, this Zoom on like my phone, I could like just send like the band name that it is.
There you go. See, look at this. Are you using your phone right now? Is that what you're using?
No, I'm using my dual monitors.
Oh, that's what I got. I got a couple monitors. Well, it looks like I'm not looking at you guys because I'm looking.
But it clocks my PC at like 125 degrees.
Oh, I know. Mine's blowing. That's wonder why. Yeah. Well, I mean, I know why. Yeah, I'm gonna have to put my laptop up on stilts, get some air underneath it. It's literally it's burning. Okay, this is fun. All right, so let's put in words what the first the three questions are saying. So here's what we can do. So let's change colors because it's nice to do that. So we can express the sentences 1, 2, and 3 into the language of math. So for 1, what do we have? 1 is the probability that X equals exactly, what did I say? I think 5, right? Was it 5? Let's go back. Yes, exactly 5. And then the second one was the probability it's at most 3. So if we look at the second phrase, how do we translate that into math? Well, that was the probability that X is at most 3. So we would say less than or equal to 3. And then the last one was the probability that it's at least 3. So we would write it like this. So what I'm doing is I'm taking those 3 English sentences and I am writing them not in English, I'm writing them in the language of mathematics, particularly the language of probability. And the reason it's useful for me to write them in this language is because then I can use formulas to quickly compute these probabilities. So if you have a question or a concern, please let me know. Someone has something they want to say. Oh my God. Is that what in the world? That is a band's name.
Yes.
Why is it so many words?
I don't know.
What is wrong with these bands? How are they ever going to get on the radio with a name like that, Liam?
I don't know. Sirius XM?
Fair enough. I wonder if they like probability. Okay, so let's now say to compute these. And by the way, you don't have to do this when you solve these problems. If you understand how the binomial distribution works, go right ahead and use it. What I'm trying to do is walk you through the thought process, the best way that I can walk you through it, being in this virtual world we're in. If you understand the binomial distribution and you just want to throw these formulas on the page and answer the question, that's fine. But I am trying to give you sort of the process, the thought process behind everything. So to compute these, we need to know what our success, quote unquote, is. So let's say that success is they want to live on the beach, and failure is they do not want to. So what is failure? It would be the opposite. Okay, so now we can figure out what our probabilities are, because we now are told in the problem what the probability of a success is and what the probability of a failure is. We know that 6% of all, I think it was 6, was it 6%? Yeah. Yeah, 6% of all adults want to live on the coast. Okay, so does anybody have a question? La, 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 la. Okay. So let's change our colors. So this means the probability of success is P. What is P? Little p is 6 over 100. And then what is failure? Failure is 1 minus P, which for short would be 94 over 100. Notice I'm not using percents. I'm using their numerical equivalent. Now, maybe you don't like 6 over 100. Maybe you want 0.06. That's fine too. Okay, so we can also think of each of the 20 people as a quote unquote quote trial. I go to the first person, do you want to live on the beach? Yes or no? Success or failure. I go to the second person, do you want to live on the beach? Yes or no? Success or failure. So thus, P, capital P, the probability of X equaling 5, what this means is exactly 5 successes out of 20 trials. I shouldn't write the word. Let's clear that. We don't need this is. Doesn't make any sense. Now again, if you were solving this problem, if it were a homework problem or an exam problem, you don't need to write all this in. You could actually just go and plug the formulas in. So that's what we're, or not plug the formulas in, but plug the, or compute the appropriate numbers in the formula. So that's what we're going to do right now. Before I do that, does anybody have a question or comment? There's a third of you at least pretending to be here today. There's 10 participants. Actually, that's not even a third. Excuse me, that's because that's me plus 9 of you. I even did my hair today.
People just don't like coming to class.
I know. Maybe they can't, though, so I would never judge.
I mean, I'm just walking like 2 feet from my bed to my computer.
There you go. Well, hey, I woke up at 9 o'clock today.
I woke up at like 5.
I'm turning back into you guys. You stay up all night and then you sleep all damn day.
I was up at 6 when my dad decided to set the smoke detector off cooking.
You guys having a fire alarm test at home?
My dad was cooking bacon. It never fails. He sets it off.
I remember like 5 years ago, like all the smoke detectors in the house just went off at once. Randomly.
Yeah, that's never good. You should have, when that happens with little babies, then you really have yourself a crap show. I was cooking the other day, it went off. My kid was freaking out.
Because your cooking sucks?
What's that?
Because your cooking sucks?
No, I just didn't put the suction fan on. If
Okay.
you don't put the fan on, then if you're cooking greasy stuff like bacon, for example, bad things happen.
Just put it in the oven, the bacon.
No. My dad normally air fries it. He decided to do it on the stovetop today.
Yeah, the stovetop's bad. Oven's the best way to do it, cleanup-wise at least.
Air fryer is really easy. You can just leave it cooking there, and then all the bacon, the grease drains off, and then you.
That's a good idea too. I never thought of that. Interesting. Might have to ponder getting an air fryer. They're cheap now.
They're really useful.
That's what everybody says. They're supposed to be the best.
I could just put it on my computer because it's at like 130 degrees.
That's a good idea too. You could fry an egg on your laptop right now. A process.
Mine's a tower, not a laptop.
Oh, really? What the hell else do you have running? Let's see what my task manager's saying. Oh my God, I'm going at 90 right now. 90% capacity. Holy.
Oh, capacity. I don't know what I'm running. Let me check my task manager.
Oh, now it dropped down to 45. Interesting.
Yeah, my CPU is only running at like 12%, and yet it decides to put my PC at. Yeah.
Some of these people are going to listen like, what in the hell are they talking about?
I could just run my desktop and it runs at 130. Then I run like a game that eats up like 100% of my GPU and it's still 130 degrees.
It's like you're doing a 3D simulation of something.
Yeah, my computer just loves being at 130 degrees.
130 degrees Fahrenheit. All right.
Yeah,
so,
and just confusing everyone else.
That's they'll have to learn. That's how you learn things. Someone has to learn what RAM means. All right. Let's answer these questions now so we can compute. So for the first one, we want to compute the probability that we get 5 successes out of 20. So we know by our formula that this is 20 choose 5. And then it's times probability, which is 6 out of 100 to the 5th power. And then it's 94 over 100. That's the failure probability. And then what power goes here? Well, it's 20 minus 5, which is 15. So there's a very easy way for you to check that you did this right. There's lots of symmetry. Notice the exponents add up to n, or 20. And then in the two fractions, they must add up to 100. So there's a way you can check yourself that you've done this correctly. Now, you're not going to pick up on that right now because unless you've done a few of these. But once you do a few of these, you'll say, hey, okay, I get what O'Grady was babbling about, even though he annoys the hell out of me. Okay, now, one of the things that happens is these numbers are difficult to often compute by hand. You ain't computing this by yourself. So one of the ways you can do this is if you look in the back of a book, they have a table for these values. If you don't look in the back of the book, you can use a calculator. Again, if you have a smartphone, there's free calculators that will do this for you. If you have access to the internet, you can have a calculator that will do it as well. So what I'm going to do is I'm going to show you how I would do it. I'm going to go slowly here. You could kill it all at once if you want to, but I'm going to compute each one of these values one at a time. So if I compute the first value, 20 choose 5, this is nothing more than 15504. And then what's the next number? The next number is 6 divided by 100 to the 5th power. Now this is an extremely small number, but I'm going to write it out for the heck of it. So if you wanted to, you can write out what that creature is. And by the way, some of your calculators are not going to give you, unless you have a more powerful calculator, you might not be able to calculate this number. For example, 94 over 100 to the 15th power. So what you have to do is you have to be very careful because you have a war happening here. If you look at this, I'm going to write this next number down, but I'm going to write it in scientific notation because it's a very, very small number. This last guy right here is 2.058911. I'm going to round it off there. Well, let's just round it off here, times 10 to the negative 16th. So what I'm going to do is I'm going to be very, very cautious. I'm going to come over here with my eraser, and I'm not going to put an equal sign because these things are not actually equal. This is approximately this value. All right, so now I'm going to go to a calculator, and I'm carefully going to, by the way, this is, I hold on a second, I have a typo. That is not correct. I hit the wrong button. Let me fix this. I hit the wrong button. Fix this number here. This is not. This number is actually a little larger than that. Sorry about that. This is roughly 0.395292. So now if I put all these pieces together, and do the math, do my calculator business. What we get is we get that the probability exactly 5 of them will want to live on the coast is 0.004765. So that's a pretty small number. Fix this. This is, hold on a second. I must have had a stroke this morning because I'm writing this wrong. Erase that. I don't know if I should blame myself or if I should blame the computer.
Or the rock star.
No, that's not it. I haven't had enough sips of that yet. Let's just round it off here. So it's very unlikely that exactly 5 people. So does anybody have a question about this calculation? Fun times, fun times. Let's check the chat to see if anybody's chatting. I doubt it though. No. Oh, I see you got your dog out there. What's happening here? Is he attacking you? That's good. Little dog. That dog reminds me of the dog. You know what movie that reminds me of? You guys probably don't even care. Anchorman. Is it Anchorman? Yeah, he has that dog. Is it Anchorman? Yeah. All right. So that problem, and by the way, I am going very, very slow here. I don't care if you go this slow, but also you don't need to go this slow. If you know what you're doing, you could have solved this problem, you know, hell, 20 minutes ago. Okay. Now what are we going to do? Okay. For part 2, we need to use some deductive reasoning. So let's use a different color to help illustrate that. We'll use this pretty little magenta or purple or something. So for number 2, we must note, and we went over this stuff weeks ago, that the probability, so we're saying at most, remember we used at most 3. So the probability that x is at most 3 is the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2, and then it's plus the probability that x equals 3. So we have to compute each one of these probabilities. Yikes. So again, if you go back to when we talked about probabilities and we said, okay, we have these addition rules and these multiplication rules. Now this was weeks ago, but the addition rule says that that's what it means. So what are all the sort of outcomes that are true? Well, the outcomes that can be true is if I get nobody wants to live by the coast, or exactly 1, or exactly 2, or exactly 3. So at most means 0, 1, 2, or 3. And then we got to compute all of this crap. So one of the nice things is if you go to your search bar, if you don't already know how to do this, you could probably go to Binomial Distribution Calculator. If you Google that, and just like that, there's all kinds of applets that will do it for you. This one is StatTrack. And so this is real nice. Excuse me, it'll actually do lots of different things for you. How cute is that? Very good. So I've actually found, if I just Google binomial distribution calculator, one of the first hits is this website called StatTrack. And it'll actually kill all these at one stone if you know how to input the numbers. So, so we can actually check that our answer makes sense. So yeah, sweet. Okay, so what I'm going to do is I'm going to use a calculator for this. And again, you don't have to use a calculator, but it's going to save yourself some time. So the probability of 0 successes is going to be 0.29. I'm going to approximate these things because they're all going to be some small numbers. So if I go to a calculator and compute this number, I get 0.2901. Excuse me. And then if I ask the probability of 1 success, I get 0.3703. So I'll just round to 4 decimal places. Then if I go to my calculator and I ask for 2 successes, I get 0.2246 if I round. And then last but not least, if I ask for 3, I get exactly 3 successes. I get 0.0860. So now what I have to do is I have to add these guys all up, and that would give me the desired probability. So if you have a question while I'm doing this, please ask. There's some interesting things happening if you look at these numbers that might be of interest to you. If you look at their pattern. So if I add these up, it looks like I get roughly 971 or 0.971, which is roughly 97% chance.
You have a question, just so you know.
Yeah, I know. What's that? I gotta open it. Yeah, okay, so someone asked what calculator I'm using. Give me 1 second, I'll show you that. I don't even know if it's the best, but I'll show you it in a second. Okay, so what I'm using is the following calculator. So I wonder if I copy and paste it, if it can. Melanie, let me know if this works. If you can, oh yeah, there it is. See if you can open that up. I just put it in the chat.
I was able to open it.
Does it work? Cool. So this is, and again, it might be a little overwhelming if you look at this thing, but the only, you'll notice that if you spend some time studying this, it's going to give you, this calculator just answered all 3 of our questions at once. Does anybody have a question? So it does work for you, Liam?
Yeah, it does. I mean, I was able to open it, but like it just looks overwhelming, that calculator. That I just instantly minimized the browser when I saw it. Whose dog keeps barking?
Is that yours?
No, those aren't mine.
Could just be someone. The other day I'm teaching, and all I hear is a car engine. And I realized someone was playing video games the whole time. I said, "What kind of criminal plays video games and doesn't at least mute the sound of their video game?"
Someone who makes it play through a speaker, not a headset, like a smart person.
Yeah, well, that's the thing. I should be using my. I should probably use or like a microphone so that you don't hear, like my headset, so you don't have to hear all the surround. But my kids are sleeping still, so you don't hear them. There's no debacle upstairs right now.
Yeah, but I have like 3 mics on my computer, which kind of sucks.
You have 3?
Yeah, my webcam, my like snowball, and my headset.
Okay. Very good. All right. Does anybody have a question about this? Melanie, can you confirm or deny that you were able to open the link?
I was able to open it.
Okay, cool. I just want to make sure because you asked. Do you know how to use it?
No.
Well, look here. If you're looking at it right now, what I would let me do something real quick. I'm gonna switch what I'm sharing to you.
I was gonna say I have mine side by side.
Yeah. So do you see it now? Do you see the web page now? So what I would encourage that you do is all you need to worry about is, so look at the thing. Look at, if you put in probability of success, notice I put 0.06 because that's 6%. And then what are my trials? My trials are 20. And then what am I looking for? Successes. I wanted to know at most 3. So I think I can annotate on this. So the optimal thing you should be looking at for your answer, if you want to do it all at once, is this thing. Can you see me circling this particular line?
Yeah.
So what this line is saying is this is asking exactly what the question part 2 was. So this is number 2 on the question we just did. And then this guy, where we say at least 3 people, this is going to be the answer to the third one. And we'll verify that ourselves in a second. So the things that you should answer, and this would be number 1, but not particularly number 1, because this would be number 1. With k equals 3. So the answers that you could get, you could have answered this question right away just by plugging in the numbers and reading off these lines. Does that make any sense?
Yeah, now that you've walked it through, looking at how to put it in, it makes sense.
Yeah, so I know we didn't use this word cumulative in class. That's okay. You don't need to be concerned with that right now. That's a more fancy phrase. But if you, really, if you want to try to make the connection, look at the inequalities. Notice, where my pen is circling, you have the less than or equal to. Now they're using X twice. I use X and K. They're using X and X. So, you're going to have to make that connection with why they're using different letters, but it's still structurally the same thing. Does that make sense?
Yes.
Okay. All right, so let's do the last problem, and let's make sure our calculation agrees with this thing down here. So this thing I have circled down here, number 3, we want to make sure we get that number. And so how we're going to make sure is we're going to compute it and make sure, check ourselves. So let me go back to the whiteboard. All right, so do you guys see the whiteboard now?
Yep.
All right, cool. All right, so for the last one, we want at least 3. So for 3, we can use a shortcut. So we had this idea that if you wanted to know a certain probability that was hard to compute, we can do 1 minus the opposite of that outcome. So, just for a heads up, if you want to know the probability of a heads, it's the same thing as a tails, right? 1/2 and 1/2. But if you're going to flip a coin 2 times and you want to count the number of heads, well, that's the same thing as counting the number of tails. So we can use the following idea. So we can use the probability that we are at least 3 is going to be equal to the probability, or excuse me, not the probability, would be equal to 1 minus the opposite outcome. What's the opposite of at least 3? That would be less than 3. And so this would be 1 minus, what's less than 3? Well, there's 3 things. That would be the probability that X is equal to 0 plus the probability that X is equal to 1. And then the only other number that's less than 3 is probability that X is equal to. Now, we computed those 3 numbers already. If you look at the previous page, we have them. So if I jump back for a second, you're 0.2901, that guy. So this is 1 minus 0.2901 plus 0.3703 plus 0.2246. And then if we add those guys up on our calculator, we get 1 minus 0.885 And if we do that arithmetic, we get we get 0.115. Now, if you go does anybody have a question about that before I switch the pages? Now, I'm not saying you have to do it exactly how I did it. If you want to use a calculator from the beginning, that is fine, unless I otherwise tell you to. If I go back and share, if I go back and share this screen again, you'll notice that the answer we got agrees with the same answer that the machine got. So if I annotate this, let's get a color, let's say red. If I look at this number down here, this is exactly what we got. If we round to 3 decimal places, 0.115, that's what we got. Isn't this fun? So I do want to remind you, and I know I sound like I'm repeating myself, but it's important you understand this. This problem does not need to take 45 minutes. I have gone painstakingly slow in the beginning, and I tried to write everything out so you could try to learn from it. I'm not saying it's the best explanation. Maybe you find better ones elsewhere. But what I am saying is if you take this, and let me go back to sharing that whiteboard. If you take this example and work through it slowly and you see, okay, I see why he wrote all this stuff down, you might learn from it. Now, again, if I were solving this problem from my own joy or because I was doing it on a test, I would have not have written out, I would have immediately went from the problem. So I would have skipped all this page. I would have skipped this page and this page. I would have went immediately to computing these things. So it would have taken us far less time if we directly solved it. But what I was trying to do is trying to give you some intuition, some motivation for how you can adapt this particular problem to similar ones. Because they're all very much the same. You just have to figure out what your X and your K's are. Does anybody have a question about this? Going once. Going twice. So what I'm going to do is I'm going to give you another assignment, and it's going to be mostly these binomial things. And again, you might say, well, why are we spending so much time on this? Well, there's a few reasons. One, it's very, very important to what we're going to be doing later. Another one, and you might not want to hear this, but some of you will maybe want to go to grad school one day. Maybe you want to go get an MBA or something like that. Well, when you have to take these GREs to get into business school or other graduate schools, they have these math sections on them. And these are the kinds of questions that they ask you. These things pop up on standardized tests a lot. So we're trying to give you a big sort of overall view of this. And hopefully you try to learn it. Does anybody have any questions? Comments? So if you guys don't have any questions, I think that we can end this now, but I'd be happy to stick around and answer anything if you have a question. And I'm still trying to figure out how we can upload these videos. I think what I'm going to do is do the private YouTube channel for you guys, and that way you can see all the lectures on YouTube. That's the goal. Does anybody have a question, comment, concern? Don't forget to submit homework so I can give you grades so you don't flunk. And if you don't have any questions, I will count to 5 and then I will end the meeting. 0, 1, 2. All right, guys, have a great weekend. Take care.